Hello. Welcome to Codespiration. Today we're going to solve another of LeetCode's favorite. That is the LeetCode 1405 longest happy substring. Okay, this question says given a string S, the string is considered happy if it satisfies the following condition. 1. S only contains the letters A, B, C. Since these are the letters we're given, S does not contain any of like each character in three places. Basically, each character needs to be appended to the result twice, maximum, before another character is selected. Then S contains at most A occurrences of the letter A. So the string cannot contain more than the number of A's were allotted. Same thing with the B and the C. So given three integers A, B, C, return the longest possible happy string. If there are multiple longest happy strings, return any of them. So there could be combinations or permutations of happy strings from our given S string. However, we can return just any one. So example 1 portrays this beautifully. We're given A with a frequency of 1, B with a frequency of 1, and C with a frequency of 7. And our output is this. We have 2 C's, 1 A, 2 C's, 1 B, and 2 C's. That is the happy string combination we can derive from the letters and frequencies we were given. Example 2 gives us 7 A's, 1 B, and 0 C, and we get an output of 2 A's, 1 B, and 2 A's. So basically, what this question requires is that we find or return a happy string with a combination of the characters we've been given in a way that no character is repeated more than 2 times consecutively. All the characters are present in the string, at least all the characters with frequencies above 0, and the characters cannot be appended to our return string more than the frequency which we were given. For example, this question gives us just 1A character. We cannot have a string that returns more than 1A, neither can we have a string that returns more than 1B, nor can we have a string that returns more than 7 C's. However, we can have a string that returns less than the amount of characters we're given if there are no other characters to satisfy our combination of not returning more than 2 consecutive characters of the same type. So the data structures we can use to make a solution for our return string, there are several. However, in our solution, we'll be using a heap, a priority queue, or in the case of Python, a max heap, so that we can efficiently manage the largest frequency or the largest occurring characters and return them in a way that we can append our highest frequency or highest occurring character as we create our return string, so that we can return as many of our characters as possible while sticking to the specification of the question, which is here in this part. So I think the first thing we need to do is to initialize our return string, which will be our return value. Then we said we would use a heap, in particular a max heap, which in Python maintains a list as the basis of its implementation. Now, to efficiently manage our characters, we need to push them as tuples to our heap so that we can consult or refer to both frequency and character simultaneously. So we can do this by saying, remember, we can only push characters or rather we should only push characters with frequencies above 0, because it would be counterintuitive to push in a character that has a frequency of 0, because that character basically does not or should not exist in our string. And considering that we will be popping out these characters from our priority queue or our max heap to build our return string, we should avoid characters that should not exist in the string. So we can just basically say these are the integers we were given to hold the frequency of our characters. We can say if a, or a, that if a is greater than 0, and now we push this particular character to our heap. And the way it is done in Python, we say heap q dot heap push, then we give our list to this operation, which is our max heap. And remember, we are maintaining both the frequency and the character in our heap. So we return this as a tuple. Now, Python's basic or default implementation of heaps implements or manages them as min heaps. That is, the minimum or the smallest character is always maintained at the first position of the heap. However, we want a max heap. To achieve this, the easiest way to do this is to append our integers as negatives. This then maintains the heap as a max heap instead of a min heap. So we make the negative of a and pass in a as the tuple, the second character or the second item in our tuple. Now we do the same for all the other characters that we have been given. We push this to heap, which is our max heap, and our tuple, or remember, negative of minus b, maintaining or mapping to the character b for referencing purposes. And same with our last character, which is c, push to heap, our max heap, and once again maintained in its negative form so that we can manipulate our min heap into a max heap. Now we need to find a way to loop through the string we have been, or rather to loop through the items in our heap while we create our return string. The logic here is to ensure we take the highest occurring character at every iteration and append that character to our list, while maintaining the conditions of avoiding appending one character more than 2 times, because we cannot have 3 consecutive occurrences of the same character. So we will be using a while loop to achieve this, and we want to loop through or continue to build our return string as long as we still have items in our max heap. So we say while max heap. Now since our the items in our heap are tuples, we can unpack by saying frequency and character. So we're initializing 2 variables to hold the individual or independent items in our tuple, and we grab that item from our heap by using the Python operation heap pop. We pass in our heap. By default, this operator goes into our heap and pops out the smallest item, which in our case, since we have appended these items as negatives, it turns out to be the highest occurring character in our heap. Now, we have this automatically unpacked by Python in our two variables, which is the frequency one and character one. So we do a little check. We say if the length, this is also a Python operator, of return value of our return value, which is the item, what we want to return at the end of this operation. If our return value, the length of it, is greater or equal to 2, that means we have 2 items already in our return value, and the last item in our return value, we can access this last item by using a negative index again, is equal to character 1, which is this character we have just extracted from our heap, and the second to the last character, which is in our result list again, is equal to, we can also access this with a negative index, is equal to character 1. This means, what this simply means is that we are checking our result, our return value, to see if the last character in the return list is equal to this character we have just received from our heap, or the second to the last character is equal to this character we have just returned from our heap. If this is the case, we simply, if this is the case, it means that we have already appended 2 characters from our largest or highest occurring character. So we need to move to the second highest occurring character. So we attempt to get this by popping another set of characters. This is why we indicated this as frequency 1 and frequency 2, because we may need to access the second highest occurring character if this particular item returned from the list is already in our result string. But before we do that, we must ensure we create a little check that we still have items in our heap, so that we do not throw an out of bound exception. So if, rather, we take the opposite, we say if not heap, we break out of this loop. That means we no longer have items in our heap, so we can no longer access items from that heap. That means we have received all of the characters from all of our different, from the combinations of all the individual characters we were given, and we need to terminate and return whatever is in our return value. However, if this is not the case, we do the same operation above, but this time around we're taking frequency 2 and character 2, and we are popping again, because now our heap has adjusted itself to return the next largest or frequently occurring item, which in the implementation of the heap would be the second smallest item as the head of the list now. So we just do exactly the same thing. We pop from our max heap, and this character and this frequency happens to be acceptable to build our result list. So we take our return value and we append character 2, because character 2 now it is a different character from the last 2 occurring characters in our result list, which is what this condition achieves. And character 2 is also the second most occurring character from the frequency integers we have been provided with. Now, because we have appended character 2, we need to adjust its frequency. Remember, we're looping through while we still have items in max heap. In order not to create an infinite loop, we need to implement the ways to ensure that this, our max heap, is continually reduced until we have no items in our max heap, so we can break out of our loop. So we achieve that by reducing our frequency, which is the current character we have just appended, which is frequency 2. We add 1 to it. Remember, our items are maintained in their negatives. So in order to decrease, we have to add 1 to it. This efficiently decreases the frequency or the amount of character 2 that we have in our max heap. Then, if we have done all of this, we need to push back both the character and the frequency to our max heap so that we can rerun our loop, and if that character happens to satisfy the conditions we have specified, we can pick back that character. So as we have explained earlier, we only push back characters that have a frequency above 0. So we check that frequency 2 is not equal to 0. We have to use not equal, not greater, since we're maintaining our integers in their negatives. So if frequency is not equal to 0, we can simply call our heap operation from Python, which is heapq.heapPush, and we push back, we pass the heap, which is our heap that we are using to maintain our data structure, and we pass the item we need to push back into that heap, which is our new and updated frequency 2 and character 2. Now, remember that we had earlier on popped out character 1 and its frequency. So we need to push back that character into our loop so that that character is also available for our next iteration. So we efficiently do that. Since we haven't performed any operation on character 1 and its frequency at all, we just go ahead and directly push that character right back into our list, or rather into our heap. So it's more or less the same thing. We call our heap and we pass in the item as frequency 1 and its accompanying character, which is character 1. Now, this is all the logic for the if case of this particular implementation. This then brings us to our else case. Now, this else case occurs only if the length of the return value, which is what we were returning at the end of this solution, is less than 2. That means we do not have sufficient items in our result list. Also, if the value of the last item is not equal to the character which we popped out in character 1, and the value of the second character is not equal to the character which we popped out in character 1. This means that character 1 is still available to us for manipulation. So down here we simply perform our operations on character 1, which is first we append character 1 to our result list. Then, since we have appended character 1 to our result list, the next thing we need to do is to adjust the frequency of character 1, which is the same way we did with the frequency of character 2 by adding 1. Since our frequencies are maintained in their negatives, this decreases the frequency of character 1, ultimately reducing our max heap so that we can come to an empty list eventually. Now, since we have operated on character 1, we need to do the same operations. We need to push back character 1 as an item, as a tuple, to our max heap so it is available to us on our next iteration. Remember, we only push characters or items with frequencies above 0. So we must do our check to make sure that the frequency of 1 is greater than 0. If that is the case, then we call our heap operator and push back character 1 and its frequency to our max heap. So we pass in our heap and we pass in our tuple of frequency 1 and character 1. Great. So we need to build our return string. The operation, or rather the function, requires that we return a string. And right now we're maintaining our result as a list. We need to build that into a string. This is a very Python-centric operation. We simply return a join of our return value. This inbuilt join operation builds a string out of an iterable, which in our case is a list. So this is the totality of our algorithm. We initialize our return value as a list and our max heap as a list too. Then we push the individual characters we have been given with their frequencies onto our heap. But we only push on the condition that the frequency of that character is greater than 0. We also push the frequency as a negative because the default implementation of a Python heap is a min heap, meaning that the smallest frequency would be at the head. But in our case, we need the largest occurring character, or rather the highest occurring character with the highest frequency to be at the head, so we can efficiently pop out this character. So we push the items in their negative to form a Python max heap. Now we loop through while this heap has items. We pop out the first item, which would be the item with the highest occurring frequency. We pop this out and unpack it into variables of frequency and character. We do a little check to ensure that said item, or rather our result list, has a length greater or equal to 2. This means that we already have 2 items in our result return value. And we also check that the last item, which is the -1 index in here, is equal to this character, which is the character with the highest occurring frequency, and the -2 has the same equality. If that is the case, it means we have already imputed or appended 2 consecutive characters of our highest occurring character to our result list. Now, the specification in our problem requires that we do not append more than 2, so we need to go to the next character with the next highest occurring frequency in our heap. We do this by unpacking the next head of our heap. However, we must check to see that there are items in our heap so that we do not trigger an out-of-bound exception. When we have items in our list, we unpack the next head of our heap into frequency and characters. We append this character to our result. We also manipulate our frequency to reduce the amount of said character we have in our max heap so that we can reduce our max heap to 0 or empty. We push back said character if the frequency is not equal to 0, and we push back the initial character we popped out, which already satisfied the condition of having 2 consecutive characters appended to our result return value. If this is not the case, then we can successfully conduct an operation on our initial character, the initial head which we popped out, which happens to be character 1. We append to list, we manipulate its frequency to be lower, and we push back if said frequency is not equal to 0. At the end of the day, we return a joint version of our iterable or our return value. Let's see how this runs. We have a bug, not callable. Okay, this should be append, sorry. And same thing here, append. Okay, so let's see how this runs. Yes, we're passing our basic test cases. Let's see how it runs against the overall number of test cases here. And it runs beautifully. It has a very efficient time complexity, since we maintained our data structure with a max heap, which is a very efficient Python data structure. So I hope this helps, and I hope this tutorial was easy to understand. Stay tuned for more of this content. Signing out for Codespiration.